Oh, great. It's you guys again. Keep checking in here. Kind of freaking me out. You're kind of like just stalking me or something. What's going on? All right, hey, let's get rolling. Today we're going to talk about compare and order rational numbers. So we're going to play with the rational numbers. Speaking of playing, it kind of reminds me of a little bit of basketball, right? I'm TallTal. I'm pretty tall, about 6'8". Let's do a little basketball. What does a basketball player do before he blows out his candles? He makes a swish. Like a wish. Buckets. Swish. Let's go. All right, let's get rolling. Makes a swish. Okay, today what we're going to be able to do is compare and order rational numbers, including integers, exponents, square roots, absolute value, percents, decimal, and fractions. Okay, that's a goal. Can we compare? Which means when we think about comparing, we're talking about which one's bigger, which one's smaller. And we're talking about ordering, we're ranking them. We're putting them in order from smallest to greatest or from greatest to smallest. Well, rational number. What are you talking about, rational number? I don't even know what that means. Well, let's go. Let's talk about it. Rational number is a number that can be made as a fraction. This is such a wordy definition, but it's a number that can be made as a fraction of two integers. An integer itself has no fractional part. So what I like to look at it as a little bit simpler is rational numbers are all integers, right? What are integers? All your counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All their opposites, -1, -2, -3, -4, -5, -6, and 0. So all your counting numbers, their opposites and 0. So those all are rational numbers. Also are fractions. Fractions that are written in like a normal form, meaning there's no decimals in the fraction. So like 3/4, 7/8, it could even be mixed numbers. 4 and 7/27. That's fine. There's no decimals in there. Repeating decimals. So you know how decimals, sometimes you see them and they're like 3.2424242424. Like it just keeps going on and on forever, but there's a pattern. So it kind of makes sense. It's rational. That's a rational number. So decimals that go on forever, but there's a pattern, like 8.333333. Or a terminating decimal. A decimal that stops, in other words. So -7.24. That's a rational number. The numbers that are not rational, just to kind of help you with, are decimals that go on forever and there's no pattern. Like pi. 3.14, blah, 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 blah. Goes on forever, but there's no pattern. Or 7.362494993, whatever. And if you're also doing a square root of a non-perfect square, like square root of 25 is what? 5. That's a rational number. Square root of 26 is 5 point something, so it's going to turn into one of those decimals that goes on forever. So rational numbers. It's very important to know the difference between rational and irrational. Okay, so let's get to work on this. Remember, we say we're putting things in order. So scientific notation, if you don't understand scientific notation, I have a video. Go check it out. It explains how these work, but you should understand how this works if you've seen my videos before. So scientific notation simply tells us we're taking bigger numbers or very small numbers and we're putting them in a format that we can understand better. All right, so for this one, the important thing for you to understand is that we are talking about these three values, okay? And then we're taking them, all of them, and multiplying them by a base 10 number. And then we have exponents that tell us, are we making it bigger or smaller? So if an exponent is positive, like these two, oh, I do not like that yellow. If an exponent is positive, we're making the number bigger because we're moving this decimal 4 places to the right. Same with this one. We're moving this decimal 4 places to the right. Okay, and if it's negative, it means we're moving the decimal 4 places to the left. So I'll take that one up there and write it here. So now we got point, that's horrible to write because I'm doing it in a highlighter, but 0.000411. Okay, so if we're supposed to put these in order of descending order, we're going down the stairs. So we're going from the biggest number to the smallest number. All right, well, it's pretty easy by looking at these to figure out which one's the smallest because the only one of them is moving the decimal to the left. So that means we're making that number smaller. We're turning it into a decimal, 0.000411. So that would be third place, all right? Descending order, going from largest to smallest. So I'm going to go ahead and say this is in third place. Now these two, we have to figure out which one's the biggest. When the exponents in scientific notation are the same, all you have to do is go over here and say which one of these numbers is bigger. Well, 4.88 is the biggest, and 2.65 is smaller than that. So that's descending order. Biggest, second place, third place. Now we want to compare in order, but we're going to try to put, this is called an inequality statement. So what we're doing is we're taking these numbers that we have here and figure out which ones of them, so there's probably going to be multiple answers, will fit right there. In other words, what it's saying is we have this 4.11 times 10 to the second, and it's got to be less than whatever number is in here. And whatever number's in here, this has to be bigger than it. So in other words, it's saying which of these numbers fit in between these two numbers. Okay? Well, remember we talked about scientific notation. We know some things just by looking at the exponents. So this one is to the second, and this one is to the sixth. So if any of these, they're all written in scientific notation. Remember, scientific notation has to have a single digit, 1 through 9, followed by a decimal and some numbers. And so all of these fit scientific notation. So which of those have an exponent between 2 and 6? So we're going to ask ourselves that. Which one of them has an exponent between 2 and 6, and they will fit in between? So this one has a 3, so it'll fit between. This one has a 3 to the third. It will fit in between. This one has a 4. It will fit in between. Okay. This one has an 8. That will definitely, that's bigger. That's bigger than anything to the 6th power. So this one will not work. 7 over here. This one has 10 to the 7th. It will not work. Okay. Now we have some with a 2. We have 2 of these with a 2 and one of them with a 6. All right. So remember we talked about if the exponent is the same, then we just look at the numbers that go with it, the coefficient. So this one is 4.11 times 10 to the second. This one is 3.86 times 10 to the second. Same exponent, so we look at the coefficient. 4.11, 3.86. 3.86 is smaller than 4.11, and that means it will not work. It needs to be bigger than that, so that one will not work. This one is also 10 to the second, but this time the coefficient is 8.22. So that means 8.22 is bigger than 4.11, so that one will fit. And then we'll go back to the last one, 7.66 times 10 to the 6th. This is 7.65 times 10 to the 6th, so we got the same exponent. This coefficient looks like it's just a smidgen bigger because it's got 7.66 and the other one is 7.65, so that one will not work. So you should have put a square here, 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 and here. We have 4 of them that will work and 4 of them that will not work. Same thing, another one. Now we're not dealing with scientific notation. Now we're looking at some other types of rational numbers, okay? So now what I like to do when I'm dealing with rational numbers or dealing with like comparing and ordering and they're like in fractions, decimals, and percents, you know, certain teachers and certain people will tell you different strategies they use. When I was growing up, my teachers always said, change them to decimals and compare them. And then one day I had a person say, decimals, I can compare them with decimals, but percents are real easy to compare. If I had 37% and you had 82%, who's got more? You do. That's just a bigger number. It makes more sense. So I've been telling my kiddos to convert everything to percentages, and then it makes life a lot easier. So you have to know how to do that, and I have a video on that if you want to go check that out as well. But so far, we have 68%, and we have 19%, and we have 36%. Let's change the rest of them to percents. Okay? So if we have the easiest ones to do are decimals to percents, because a decimal to percent means you're just multiplying it by 100. So 1.67, move the decimal. When you multiply by 100, you're just moving the decimal 2 places. So now we have 167%. We have this decimal right here, 0.9. Let's move it over, add that 0, and now we have 90%. Okay, this decimal right here, we have 0.6888888 forever. Move the decimal 2 places, and you're going to have 68.8 on forever percent. Okay, now we're going to look at 1/2, and we're going to change that into a percent. Now fractions are a little different, but all you got to do is get it over 100. Any number over 100 is a percent. Okay, so that means let's just set this 1/2 equal to 100. So I have 1/2 equal to a fraction that has 100 on the bottom. Okay, and then you just have to know how to make equivalent fractions. Equivalent fractions means whatever I do to 1 to the bottom, to the denominator, I have to do to the numerator. How did I get from 2 to 100? Well, I multiplied because I got bigger, and I multiplied by 50. And if I multiply the bottom by 50, then I multiply the top by 50. 1 times 50 is 50. So 50 over 100, again, is a percent. 50 over 100, you just take the top and you put a percent sign after it. Okay? Then we can say, let's do another one. Let's do 2/5. Okay, so if I have 2/5, set the bottom to 100. And what did I do from 5 to get to 100? Well, I multiply 5 times 10. No, that's 50. Multiply 5 times 20. 20, 40, 60, 80, 100. Yes, I multiplied the bottom by 20, which means I have to multiply the top by, yeah, I know, 20. Got to multiply by 20. Always yelling. What's 2 times 20? That's 40. Anything over 100 is a percent, so 40 is our percent. And then one more time, we have 3/4, okay? So let's turn 3/4 into 100. Let's set 3/4 set to a fraction over 100. What did I do to get to 4 to 100? Well, if you like money, you know 4/4 equals $1. So 4 times 25. So I multiplied the bottom times 25. So you guessed it, I got to multiply the top by 25, and I get 75 over 100. Anything over 100 is a percent. That is our percent. Now we have all the data we need to solve this problem. So now we just need to go look at the numbers and see which percents. Oh, let's turn this into a percent, by the way. 0.19 at the beginning. 0.19 turn into a percent, move it 2 places to the right, is 19%. Now we just need to find all the numbers that fit in between 19% and 68%. And since all of our answers are percent, that should be pretty easy. All right, so let's go ahead and look at that. Is 40%, let's look at this first one, is 40% between 19 and 68? Yes. Is 167 between 19 and 68? No. Is 36 between 19 and 68? Yes. Is 50% between 19 and 68? Yes. Is 90%? No. Is 75% between 19 and 68%? No. Is 68.8% between 19 and 68%? Tried to trick you with that one. This 0.8 means it's bigger than 68. It's a little bit more than, it's 68 and some. So that one will not work. And will 19% work? No, because it's the same value as that one. Now, remember, if this thing had a line underneath it, if there was a line right here up top, that would mean less than or equal to, but it does not say less than or equal to, so therefore this one does not work. Now, let's take this on a much easier scale by just comparing two numbers. What's the easiest thing to do? Turn them into percent. How do you turn decimals into percent? You simply move the decimal 2 places to the right. 1, 2, which gives us 77%. Which is bigger, 77% or 85%? 85% is bigger. How do we do that? We use the one that opens up to the bigger side. Let's try another one. Place these in descending order, okay? Descending order means from largest to smallest. Well, before we go doing any math, sometimes you just want to look and see your understanding of numbers and see if you can figure any of these out by just looking at them. Anything stand out as glaring that says one of these is clearly bigger than the other one? Yeah, you're right. There's only one of these that's positive. So positive is bigger than negative numbers, so that is our biggest number because everything else is negative. Okay? Now, we have to figure out how to turn these into percents so we can compare them. All right, so we already have negative 82%. How do you turn a decimal into percent? You move it 2 places to the right, and that gives you a new decimal, or it gives it 66, so we have negative 66%. Okay, negative 1/3. Now we have to set it to 100. And this is one of those benchmark fractions that you need to know because 3 doesn't go into 100 evenly. Okay, but 1/3 and 2/3 are ones you need to know and just memorize. It's pretty simple. 1/3 is 33%. It's 33.33333%. Okay, 2/3, you double that, 66.66666%. So this one is negative 33%. You could have still done that on a calculator or did 1 divided by 3 and you would have got 0.333333, and then you would have moved the decimal and you would have got this answer as well. All right, so now we've got the other answers that we need, and we're going in descending order. All right, so remember, we're getting smaller. So what's the next smallest number in this list? Okay, what is the next smallest number in this list? Okay, yep, it's this one. Okay, negative 33%. Because remember, we're looking at a number line, and we are going in the negative directions. The numbers, this would be 33, negative 66 would be like right here, and negative 82 is going to be farther down the line. So this would be second, this would be third, and this would be fourth. They just get smaller and smaller as they go down to the left of the number line. All right. The same thing, put these in ascending order. Use what you understand about scientific notation. You don't have to solve all these. You have to figure out what you know already just by looking at them, and then maybe you got to do a little bit of work. Ascending order, which means we start at the bottom and we ascend up the steps. So what is the smallest number? Well, in scientific notation, it's all about those exponents. Which one of these exponents will make our original number the smallest? Yeah, it's going to be the one with a -5, because that means we are moving the decimal 5 places to the left, which means we're going to have more zeros at the front. So this is our smallest number. And this next one says we're moving it, it says we're moving it 4 places to the left. Okay, so if that's the case, sorry, I hit the wrong button. If that's the case right there, that means we are going to have some more zeros in front of it than these 2 that are at -3. So this would be the next smallest one because it has 1 less 0 than these 2. Okay, and now finally we got 2 that match. Okay, they're only moving the decimal 3 places to the left. So now we look at them and say, okay, we're getting bigger. So which one of these 2 is smaller? Because that would be the next in line. Well, what's smaller, 1.44 or 8.4? When you have the same exponent, all you got to do is look at the coefficient. 1.4 is smaller than 8.4. Make sense? So that's how you solve that. Just got to look at the numbers, and if they're in scientific notation, use scientific notation to make your life easier. If they're fractions, decimals, and percents, I recommend moving them all into percents, because I think that makes life a little easier. All right, I think you guys are ready to rock and roll. Good work today. Proud of you guys. Thanks for coming and hanging out with us as a math rock star. And what did the almond say to the psychiatrist? Everyone says I'm nuts. Woo, cuckoo for Cocoa Puffs. I love it. You guys have a wonderful day.